All right, section 3.2, complex numbers. Our objective for this lesson is going to be define and use the imaginary unit I. We're going to add, subtract, and multiply complex numbers and find complex solutions and zeros. Okay, so where this whole idea of an imaginary number came from and what an imaginary is, where it came from was the idea of a quadratic, for an example, x squared equals -9. Not all quadratic equations have real number solutions. An important word there is now the real numbers. And really up till now, everything you've done in mathematics has been a real number. Okay? But for example, this equation, x squared equals -9. Okay? If we were to solve that, we're looking for what number times itself is -9. It might be like, well, there's no number times itself that's -9. Because when we go and square root both sides, we'd have x equals plus or minus the square root of -9. And when we type that into our calculator, the square root of -9, okay, if you notice here, we get non-real answer. So the answer to this is not real. Okay, so when they were, way back when we were first solving quadratic equations, they're like, well, we want a way of representing the solution to this type of an equation. So to overcome this problem, mathematicians created an expanded number system of numbers using the imaginary unit I. And they decided, let's go ahead and let's let I, lowercase I, and I always put a little tail on it so it doesn't look like a 1. The lowercase I is equal to the square root of -1. So then, when we have a problem like this, the square root of -9, we can break the -9 up into a -1 times 9. Because if I multiply those, again, we would get to -9. And then we can split it up, the square root of -1 times the square root of 9, just like when we were simplifying square roots. The square root of -1 is I. The square root of 9 is 3. So this would be the same as 3 times I. Okay. So then the square root of -9 is 3i. So we would say the solutions to this equation up here would x equals plus or minus 3i. So now we have a way of representing that solution. Okay. So if I equals the square root of -1, then I squared equals, well, let's look over here, the idea of I squared. I squared, that's I times I, which is the square root of -1 times the square root of -1, which is the square root of -1 times -1, which is, what, the square root of 1? So then I squared is -1. Okay. So when I take this number and square it, we get -1. Because again, this would be -1 squared, so the square root of -1, -1. Okay, so now, before when we take the square root of a negative number, we'd be like, oh, no solution. Well, now we know, no, it does have a solution. Its solution is just an imaginary number. It has that I in it. So now when we take the square root of a -25, we won't just write no solution. I can rewrite that as the square root of -1 times 25. Break it up, just like we're breaking up square roots. So this would be the square root of -1 times the square root of 25. The square root of -1 is I, the square root of 25 is 5, so we end up getting just 5i. Okay, right? Okay, and that's all this is saying up here, the square root of a negative number, we just break it up into. Okay, and a lot of times then we skip these in-between steps and go straight from here to here, because we know the square root of a negative is I, and the square root of 25 is 5. So I know the square root of this negative is I times the square root of 72. Well, 72 isn't a perfect square, so let's find a perfect square in 72. Again, remember our perfect squares are 4, 9, 16, 25, 36, ... So I'm looking for a perfect square in 72. Let's see, 72, I think 36 goes. 36 and 2. So I'd have I, the square root of 36, times the square root of 2. The square root of 36 is 6. So we'd have 6i, the square root of 2. We normally always put the I behind the number, so we have 6i, the square root of 2. So now we have negative 5, the square root of negative 9. Well, the square root of the negative is I, so we'll have negative 5I, the square root of 9. The square root of 9 is 3. So we have negative 5 times I times the square times 3, which is negative 15I. Really, with the I, we treat it a lot like a variable, honestly, when it comes to simplifying, adding, subtracting, multiplying, so forth. We treat it like a variable. Okay, so pause the video, and I want you to do your turn, problem 1, parts A, B, and C. Attempt, write something down for every single problem. Please do not come to class without writing something down for all 3 of those. Okay. All right. So now when we take our imaginary numbers for our complex number, what is a complex number? A complex number is the sum of a real and an imaginary. Okay? And we write it in standard form as A plus BI. Okay? Where we have just a real number, this we call the real part, and then an imaginary part with the I. Okay? For example, 4 plus 3I. My real part is 4, my imaginary part is 3I. And like I said earlier, we treat the I a lot like a variable, meaning these aren't like terms. I can't add them. This has an I on it, this does not. This is imaginary, this is real. You can't add the two. Okay? Okay, so again, an imaginary number is a number with I on it. Okay? A pure, so this is an imaginary number. 4 plus 3I is an imaginary number. When I'm talking about a pure imaginary number, it has no real part. It has no real part, so like just 6I is a pure imaginary number. Oops, sorry for the bump. Okay, so just 6I is a pure imaginary number, where 4 plus 3I is an imaginary number. The whole thing together, that we call is just an imaginary number. Okay. All right, so let's turn the page and let's see, what does this mean for our number system? Okay. So in our number system, okay, we've been dealing with this part of our number system, our real numbers, our rational numbers, our irrational. Okay, so let's go ahead and let's kind of review what these are. Again, our real numbers, any number we dealt with so far. Our rational can be written as a fraction. So whenever we think rational, think fraction. If you can write it as a fraction, 1/2, 0.25, because you could write that as a fraction. 0.1 repeating, because you can write that as a fraction. Our irrational numbers cannot be written as a fraction, like the square root of 2, pi, any of those types of numbers. Our integers then are just the whole numbers and their negatives. So like -4, -3, -2, 1, 0, plus 1, 2, 3, so forth and so on. Our whole numbers then is if I remove the negatives. So my whole numbers are just 0, 1, 2, 3, ... My natural numbers, then I drop off the 0. It's just 1, 2, 3, 4, ... Okay. So these are the numbers that we've been dealing with up to this point. Now that we can include the imaginary numbers, so we have our real, but over here let's add a new box, and over in this box is our imaginary. Is our imaginary numbers. We put the real numbers together with the imaginary, and that's our complex number system. So we've only been dealing with this 1/2 of our complex number system. Okay, so our complex number system again is A plus BI. If the imaginary part here is 0, so if B is 0, then we have a real number, meaning there's no imaginary part on it. Okay, so if our B part is 0, meaning there's no imaginary, then we just have the real part, and it would be one of our real numbers. So if that B right in there, so if you have no imaginary part, then you have a real number. Okay, if you have an imaginary part, well, you could be imaginary. Okay, but then we also have underneath imaginary, we have our pure imaginary. I should draw that box bigger. And that is if A is 0, meaning if there's no real part to it. Okay, so if A is 0, then you have a pure imaginary. For example, 7i is a pure imaginary. So an example of imaginary would be 3 minus 2i, where my real part is the 3, my imaginary part is the negative 2. So an imaginary number has both a real and an imaginary part. Okay. For two values, for two complex numbers to be equal, the real part has to equal the real, and the imaginary part has to equal the imaginary. So here, if we want to find the values of x and y that satisfy the equation, the real part, again, is the part without the I. So this is my real part, 2x. My real part in this number is 10. So for these two complex numbers to be equal, the real part has to equal the real part. And the imaginary part, which in this case is the negative 7, has to equal the imaginary part on that one. So imaginary has to equal imaginary. So the real part, the 2x, has to equal the real part on the other number. So x would have to be 5 if we solve that. And then here my imaginary part, which is the negative 7, has to equal the imaginary part on the other one, which is y. So y is negative 7. So real has to equal the real part, real has to equal real, and imaginary has to equal imaginary. Okay, that's an I. Imaginary has to equal imaginary. Okay, so now pause the video. I want you to do your turn number 2. Okay. Right. So now adding and subtracting complex numbers. We treat I, again, just like a variable. So when you're adding and subtracting complex numbers, you add or subtract like parts. Meaning, you can add a real to a real, and you can add an imaginary to an imaginary. But you can't do anything when you have a real plus an imaginary. You just put the two pieces together. Okay? So here, if I have 8 minus I plus 5 plus 4i, take the real and add the real. So 8 plus 5, real part plus real part. 8 plus 5 is, so what, 13? Okay? And now imaginary from imaginary, that's a negative I and a 4i. So I have negative I and 4i, that gives me 3i. So when I put this complex number together with that complex number, I get this new complex number. Okay. All right, part B. So again, take real and real, but it's a negative. So to prevent me from having issues with that negative, I'm going to distribute that negative into here because I'm subtracting the whole thing. So I'm subtracting 3, and then I'm subtracting a negative 6i, so plus 6i. Again, same part, real and real. So 7 minus 3, that's 4. Real and real. Negative 6i plus 6i, that's 0. So when I add this complex and this complex number, I get just a pure real number, 4. Okay. All right, now let's do part C. So here I have a real number 13. I want to subtract 2 plus 7i, so I'm subtracting this whole thing. So let's distribute. 13 minus 2 minus 7i, and then I want to add a 5i onto the end. So again, like parts, real and real. 13 minus 2, that gives me 11. Negative 7 plus 5 gives me minus 2i. You treat it very similar to a variable. Okay. So if you're stuck, think of it as an x. Okay. All right, next page, multiplying complex numbers. Again, you multiply them just like they're an x. You distribute when you're multiplying complex numbers. So you just distribute, just like if it was an x. Okay? The only thing to keep in mind is remember that I to the second is equal to negative 1. So whenever you have an I to the second, we need to replace it with a negative 1. Okay? So let's go ahead and let's multiply some. So again, we want to distribute 4i times negative 6. Again, think of it as an x. 4x times negative 6 would give me what? Negative 24x, negative 24i. Now I need to take 4i times I. Again, think of it as x. That'd be 4i to the second. Now here's where this little remember part. This I to the second is negative 1. So this is the same plus 4 times negative 1. So that makes that a negative 4. So my real part is negative 4. My imaginary part is negative 24i. Again, when writing a complex number, you always want to write it as a plus bi. We always want to write it that way, a plus bi. Sorry, I kind of squished these in here a little bit. Okay, so now let's go ahead and let's distribute. Let's, again, multiply. We're taking 9 minus 2i, that's a complex number, multiplying it by negative 4 plus 7i. So again, we distribute. Let's multiply by the 9. Times negative 4, negative 36. 9 times 7i gives me 63i. So multiply by the 9. Now let's multiply by the negative 2i. Negative 4 gives me positive 8i. Negative 2 times the 7 gives me negative 14i to the second. Okay, put together like terms. So I have negative 36. 63i plus 8i gives me 71i. And then minus 14. Ooh, I have an I to the second. That's negative 1. So negative 14 times negative 1. So we have negative 36 plus 71i. Negative 14 minus 1 gives me plus 14. So let's put together our real parts. Here we have two real parts. Negative 36 plus 14 gives me 2, 1. Negative 21 plus 71i. And there's my solution complex number. My real is negative 21. My imaginary part is 7i. Okay, now pause the video. I want you to do your turn problem 5, part A, B, and C. Again, attempt every single problem before you come back. Okay. Complex solutions and zeros. Well, now that we know how to take the square root of a negative, we can now solve equations that we used to have to write no solution on. Okay. For example, like when we had x squared equals negative 9 previously, when we square rooted both sides, we'd have plus or minus square root of negative 9, we would write no solution. That's how we used to solve them. But we don't have to write no solution anymore. I now know that x is equal to plus or minus 3i, and now has a solution over the imaginaries. So we solve the same way we've been solving, except now that we get a square root of a negative, we can simplify it. Okay, so here, example 6. X squared plus 4 equals 0. So I have an x squared, so I'm going to subtract the 4 to the other side. So I have x squared equals negative 4. So now at this point, we square the root both sides. X equals, again, we can't forget our plus and minus. That was from a previous lesson. The square root of negative 4. Now instead of writing no solution, I know the square root of a negative is I. So this ends up being plus or minus I. The square root of 4 is 2. So plus or minus 2i are my solutions there. Okay. Let's do part B. So I have an x squared. I don't have any x's, so let's get the x squared by itself. Let's add 11 to both sides. Oh, 6, negative 36. Divide both sides by 2. X squared equals negative 18. Now square root both sides. So x equals plus or minus the square root of negative 18. Well, again, we used to write no solution for this, but I don't have to. I've got a negative, so that's going to give me my I. Let's bring it up over here where I have more room. So we would have, let's split up x equals plus or minus, we'll have an I. Let's split up the 18 into 9 and 2. So where 9 is 3, so plus or minus 3i, the square root of 2. Here's my solution. All right, so now I'd like you to go ahead, pause the video. I want you to do your turn problem 6, part A and part B. Attempt them. Again, the first thing I did here was isolate my x squared. This is just like the last lesson that we had was solving using square roots. Now example 7, we want to find the zeros of this function. Again, if you remember what finding a zero means, is we want to find x that makes it 0. So we're going to find what x's do I put in that make this thing 0. So to do that, I set that thing, the 4, let's write it over here. Sorry. 4x squared plus 20, I want to figure out what makes that 0. So then, once we have it written like that, we solve it just like we solved example 6. Get the x squared by itself. 4x squared plus 20 minus 20 equals 0 minus 20. 4x squared equals negative 20. Divide both sides by 4. X squared equals negative 5. Now we get rid of the x squared, square root both sides. X equals plus or minus The square root of -5, well, that's going to be I, the square root of 5. So those are the values that make that thing 0. Okay, so now I want you to do your turn number 7. Okay, come to class ready to discuss. Jot down any notes you had, any question you were confused on, anything I did that you didn't get, and come to class ready to ask questions. Good luck.